Hello, welcome. Thank you so much for being here. I'm Emily Binder, Chief Marketing Officer of SignalLabs. We are here to unveil a brand new category called attention infrastructure. This is something that I think in about a year, a lot more people will be saying, much like in the moment, fall of 2022, LLM was a term only people in AI and machine learning were really using, and now it's part of our lexicon. Attention infrastructure, systems of attention. You heard it first here today. We are launching that. This is the missing layer in every enterprise stack. Here's how the evening unfolds. Our CEO and founder, Rajeev, will present a keynote where he shares the SignalLabs story and vision, followed by a fireside chat with Dr. Adam Gazzaley, where they will explain how the brain focuses. It's about attention and what institutions can learn from that. After that, we'll close with a demo of SignalOS and SignalGraph. Then there will be time for questions, so please hold them till the end. And you're welcome to take photos and videos in here in the cafe. Please keep the photos only to the view, not the inside of the room. Also, we are at Attention Signal on social media. It's ATTN Signal, Instagram, LinkedIn, X. Tag us. We would love for you to share your insights and photos at Attention Signal. And we are all really thrilled to be here and share what we've been building for the last few months, and excited for you to hear all about it. So with that, please welcome our CEO and founder, Raj.
Thank you, Emily, and good evening. I think to understand why this moment matters, I think it helps to zoom out. Thousands of years ago, I think the first known form of computing was through a device called the cuneiform, which was a clay tablet on which I think for the first time ever, human memory was externalized. So agreements, obligations, contracts, claims even perhaps, were all written down in this tablet. Now, thousands of years later, computing, of course, scaled as massively. And I think some of us were around in 1945 when ENIAC was invented. I'm not going to name names, but during the Q&A, we could talk about that. But I think externalizing memory alone is not enough. I think there's more to it. So if you turn to the world of enterprise, for the last 3 to 4 decades, I think we've been working on various forms of technology, systems of record, essentially stored the operational truth, the ground reality of what's happening in our businesses. ERP systems, SAP, Oracle, CRM, databases, all of those systems of record have done a fantastic job of saying what is the ground truth. And around the turn of the century in 2000, as distributed computing started to emerge, N-tier architecture started to emerge, we were able to separate data from engagement to insights. And that's when systems of engagement started to come into focus. These are, as you all know, workflow systems, collaboration systems, systems that engage users, systems that facilitated collaboration between various teams. And then, of course, systems of insights, data warehouses, data lakes, and dashboards, business intelligence software. All of that started to make sense of the data that was in systems of record, in systems of engagement, and started to sort of translate data into insights. And now we know that AI is permeating all these layers. Agentic AI, large language models is a new model every day, and massively either augmenting or deprecating these systems. And as investors, as users, as enterprise customers of all of these capabilities, it is a very confusing time. And yet, despite all these investments, there's something that is dramatically wrong, which is that since the year 2000, over half of the Fortune 100 companies that existed back then no longer exist now in the shape that they once did. Now, that's great, or not, for the ones that are not here. But think about the Fortune 100 list today and what that will look like 3 years from now, 5 years from now, 7 years from now. Why? Because the pace of tech is changing so rapidly. There's a new disruption that comes to us every day, almost. And so in the last 25 years, where the pace of technology has been pretty fast, it's only accelerating, and it's accelerating exponentially. So if that's the case, then what happens is just having a good strategy is not going to be enough. Having great execution against that strategy is not going to be enough. What's missing? Our hypothesis as Signal Labs is what's missing is an architectural element. And despite decades of investments, companies have really not connected things that matter, signals, across silos in an enterprise. Dating back to the 60s, companies have been organized by departments, by functions, and those functional boundaries haven't really changed despite every enterprise being flooded with signals. Signals from customers, signal from processes, signal from markets. But most of these signals do not turn into action. Why is that? Well, because those signals are trapped. They're trapped in dashboards. They're trapped in archaic legacy systems. They're not connected. They're organized by department. They work on different clock speeds. They're lost in workflows. So the bottleneck is no longer access to information. It's no longer access to AI. One could argue AI is a commodity because it's so widely and ubiquitously available now. I think the bottleneck is institutional attention. And in this agentic era, I think this bottleneck becomes the defining constraint. And there's a parallel here that matters. I think Herbert Simon in 1971 said that, the wealth of information creates, the poverty of attention. And in some ways, the Google research paper in 2017, the Transformers paper that essentially taught that machines were to focus, it changed everything for AI. The machines learn where to look, but the institutions still haven't. There's not a native way in which the most important signals across functions, across time, across context, when is it sufficient, when should one act on it? There's no layer that connects all of that. And that's what's missing. And in that missing layer lies an opportunity. And so that's where Signal Labs comes in. And we make a simple distinction, a distinction between data and signals. And, so let's start with data. So what is data? Data is logs, they're black and white, it's transcriptions, it describes the real world. Now, signals are something different. They're dynamic, they demand attention, it carries significance, it carries context, and it carries the potential of action. Data does not. And this shift matters because institutions do not act on raw data. They act on signals that are strong enough, connected enough, and timely enough. So what we're building at Signal, think of it as the atomic unit of what we're building on is the signal, not data. So if you think about systems of record, systems of engagement, systems of insight, AI for that matter, the atomic unit is data. There's nothing that exists today where the atomic unit is the signal. That's what is different about it. And that's the new layer that we're introducing into the ecosphere based on signals. And we're calling that category systems of attention. Not dashboards, not more alerts, a new system for deciding what matters and learning in time before the signal decays. So that's the category, systems of attention. How does that work? So here's our architecture at Signal Labs. First is SignalOS. Think of that as the executive attention layer, where leaders, operators, team leaders, subject matter experts can convene and examine the things that matter. Now, what matters could be assembled by AI, passed through, filtered through human judgment, and with a shot clock on it that says, here are the signals that matter, here's when they expire, here's what the decay rate is. If you act on it, here's the outcome. If you don't, here's the consequence. But in order to do that, there's a lot of math and science that goes into it. Our secret sauce for doing all of that Jeff and Plamen are going to talk about a little bit later, is called a SignalGraph. So think of SignalGraph as the layer that coordinates the intelligence. It collects the context. It reads your emails. It reads your Teams messages, your Slack, puts all that together and say, what is the institutional context of any particular signal? And how does this all come together? And think of that graph as this living, breathing entity that represents the signal truth of the enterprise. Together, SignalOS and SignalGraph create a new type of an operating system for the enterprise. Now, I frequently get asked this question. Well, why can't agentic AI do this? There's an agent for everything. Well, let me show you why one great agent is not sufficient for this.
There's no time. Take the shot. I say take the shot. I can't, I may hit Bond. Take the bloody shot.
It's good. Well, instinct matters, but instinct alone is not enough, and instinct without coordination does not create results. Don't worry, Bond will be back. But let's move from the tough world of AI or MI6 to the equally unforgiving, or if not more unforgiving, world of claims. And let's take a simple example of an innocuous claim that shows up in any number of health plans today. On the surface, it may look routine, a $4,200 claim, which is about a slightly more than average dollar volume of a claim. But around that one claim is a universe of signals: financial signals, clinical signals, utilization signals, fraud signals, operation signals, member experience signals. On each of their own, they may seem small, but collectively they tell a story. As a single claim kind of works its way through the system, a provider pattern emerges, a practice pattern emerges, a planned medical loss ratio problem emerges. And when these signals are perishable, every second of attention matters. And sometimes it is existential. Now think about this with SignalGraph and without SignalGraph. So a claim arrives, that's when the life begins in a health plan. But think about what happens before a claim actually arrives. T-minus 30 days, a patient might schedule a visit. Just that scheduling of that visit has a implication to this term called IDNR, incurred but not billed. So patient scheduling something would mean that a service is likely to be rendered, it's about to be incurred, but there's no record of it for the health plan. So that's an action. Could it cause a deviation from what you reserved? Could it cause a deviation from your expectation? Likely yes. T-minus 14 days, you could notice a pattern that 3 small providers have a spike in prior authorizations. Is that a random anomaly? Is that a pattern that needs to be accounted for? You might see upcoding patterns for certain types of codes. Again, a different department might look at it. Utilization might seem off. And then day 0, the claim arrives. Now look at it through the lens of SignalGraph. It does something different. T-minus 30 days, it connects the IVNR reserving problem. T-minus 14 days, it's connecting the EMR utilization question. T-minus 2 days, it might be detecting the upcoding pattern. It is looking at context. It's looking at patterns. It's looking at risk. And in some ways, the SignalGraph forms the hypothesis before a claim shows up, as it should. Now, that's great, but it only matters if that hypothesis translates to action. So this is where the operating system what Signal Labs is building comes to life. And in 4 loops, if you will. The first is the equilibrium engine that Jeff and Plamen are going to talk about. Validates that the action is required, that the signal is strong enough, that it's not a false positive. Because not every anomaly, not every pattern deserves action. But when it does, it requires very coherent, enterprise coordinated action. So that's step 1. 2, then, the intention has to route to the appropriate leaders with stakeholders. And imagine the average health plan that's got 17 departments looking after all the events that I just laid out. They all need to coordinate in real time. How do we do that? Well, we need an attention routing mechanism that convenes the attention of the people that need to get together. 3rd, the decision executes. We're going to renegotiate a contract. We're going to look into this upcoding pattern more carefully. We're going to send an agent to investigate this further. And that decision then gets recorded as memory. This is what we did. This is what happens. And that memory compounds over time. Every single decision that's recorded with the full context. Imagine now that the institutions can over time become smarter, more intelligent, and compounding intelligence. And without that loop, the organizations discover too late. And they're reacting. This is what happens every day today. With it, you can act in time. But to act in time, the signal has to be strong enough. And there's got to be a shot clock that says, if you don't do this by a certain time, a certain date, this is the consequence. So that's the difference. Now, that's the architecture. Now, the question is the market ready for this? Are we pushing a rock up the hill? Well, unquestionably, in our view, that the market is ready for this. And it only matters if the market's sending a strong and a clear signal for it. Well, we're seeing some signals already, and that's everyone asking the question of what's the future of SaaS, what's the future of systems of record, what's the future of systems of engagement. We all know about the SaaS apocalypse, investors, users, everywhere. But let's kind of pivot the attention to what Signal Labs is seeing. We have active conversations with over 50 customers across healthcare, financial services, cybersecurity, freight, transportation, industries that I personally don't have much experience with. But as we laid out these use cases and we laid out the technology and we laid out the description of what we're doing, there's been a tremendous amount of interest. And that matters. We've got early wins and a contract value that exceeds $25 million already. And we're fortunate enough to work with some leading venture capital firms, leading design partners that are informing what we do. So the best category ideas are not invented in ivory towers, not invented in theory. They're discovered when the market already sees a pattern. And that pattern is what we're naming and calling out as a category, systems of attention. And then the architecture of what the product that then defines it is helped and defined by the attention infrastructure. That's what's happening here. So we're entering a new era. It's a cliche, I know. But think about it. This is an era in which machines can generate infinite information, infinite summaries, infinite synthetic reasoning, and infinite recommendations. But that does not make human attention less important. If anything, it makes it scarce. And therefore, more valuable. And so who's going to win? It's not the institutions with the most data. It's not the institutions with the best AI. It's the institutions that are attention native, that can recognize a signal, understand the decay rate, and says, we got to act now. This is the future that we're building at Signal Labs. Why? Because signals are perishable, attention is finite, and memory compounds. Thank you. Thank you.
Okay, great. Well, thank you, Raj. That was amazing talk. I'm sure we all enjoyed it, and I feel like I learned something new every time I hear you speak, and it's been several times this year already. So my name is Adam Gazzaley. I am local. I work at UCSF, University of California, San Francisco. I've been on faculty there 21 years. I'm a neuroscientist and a neurologist, so I do both work on the science side of the brain and also the neurology side. And I am also the founder of a company called Gazzaley, which we'll talk a little bit about, but it's building a digital, actually video game treatment for ADHD. So do a little bit both on the academic side and on industry side.
In 2016, you wrote a paper called The Cognition Crisis. And I think if anyone asks ChatGPT or Claude, I think your name comes up most when we talk about cognition crisis, and matters related to the clinical condition of cognition. Now, of course, we're applying this in an entirely non-clinical context in institutions. And in one of your books, there's a great chapter around top-down reasoning, bottom-up reasoning, context, consciousness. Do you mind just maybe riffing on that and connecting some dots here?
Sure. That's like the whole history of the universe. I love it. Yeah, well, first of all, I always feel the need to thank Raj when we're talking about this topic, because when we met, the cognition crisis was not a piece that I had written. It was an idea that I had, and Raj actually helped support the writing of it and the publishing of it when he was at Deloitte, and very thankful. It helped consolidate a lot of the thinking in my mind. It's actually a piece that I wrote after a book that I published called The Distracted Mind, Ancient Brains in a High-Tech World, sort of a evolutionary perspective on what's great about our brains, what makes our brains so strong and unique and makes humans thrive as we have, but how the world that we live in now is so different than the one we evolved in and how it challenges us so greatly. And then the cognition crisis was just taking that even further. These are two concepts, the distracted mind and the cognition crisis, that have not died out since I've written about them. If anything, they continue to increase. I think AI has even aggravated it more. Yeah, I'll try to break down a little bit about attention for you now, and especially in relation to what Signal Labs is doing. It's really fun for me every time I learn more about Signal Labs, because I, like we all do, view the world through the lens that we know. And the lens that I know is the brain. I've been studying it for 35 years, been studying attention as my main area of focus for 25 years now. And as I see what's being created in Signal Labs, is this more and more every time that connects with how the brain works and the need for this. So attention is a massive topic. I could easily talk for 2 hours about attention, even though it seems like we know what attention is, right? There's actually a very famous quote by William James that everyone knows what attention is. And it's sort of true. Like, it's almost, just part of our lexicon. It's what we live by. It comes up almost in, at least one conversation a day about attention, and it's core to our functioning. We know that whether we're trained as a brain scientist or not. You know how attention plays a role in your life just through your experience as a human being. But it's actually very complex. And it's complex in terms of how our brain produces this emergent property that we call attention. It's also complex in the fact that attention doesn't exist as an island, just like nothing in our brain does. It interacts with memory and decision-making and perception and emotion. And that's what I've been studying. Three things. How neural networks in the brain, connections between brain areas, lead to our attentional abilities, how it intersects with all these other aspects of cognition, very similar to what you described, bringing up memory and decision-making multiple times. And then how it goes wrong, and how it goes wrong in conditions. The most obvious is ADHD. It has attention in the name, but it actually goes wrong in pretty much every condition related to the brain. As a matter of fact, you could search anything in Google Scholar, put in any condition, schizophrenia, traumatic brain injury, lupus, anything that affects the brain, and put attention, and attention declines. It's a large network property of the brain. It's quite vulnerable. It takes a long time to develop. Most 18-year-olds have not fully developed their attentional system. Parents are probably well aware of that, but the neuroscience shows it's not even until 23 or 24, and it declines basically starting at like 27. You got like 3 great years at the pinnacle of the attention pyramid, and then it's just downhill. And so it's sensitive to aging, it's sensitive to development. It is involved in every neuropsychological condition, every neurological and psychiatric condition, and it's just critical for everything we do in our lives, from our work to our relationships to our health. Everything is connected to attention. So it's a great area of research focus. So that's just like a little setup, because attention is core to what I do and it's core to SignalLabs. So I just wanted to really give attention the focus, no pun intended, I constantly do that, but that it deserves. So as I said, attention's massive. So I'm going to just talk about one aspect of attention now as it really relates to SignalLabs and what it's trying to accomplish. If you go back to the beginning, not the biblical beginning, we're going to step a little further, but single cell organisms on the planet where we came from. And you look at how they interact with their environment, there's these two prominent features that exist. They sense basically the chemicals around them through sensors, and then they move in response to it. They move away from toxins and they move towards nutrients. This is there's no nervous system, but this is the beginning of the nervous system, and this is the beginning of the attention system. Signals for these little creatures are driving their behaviors that cause them to live or die. This is a strong evolutionary basis, right? If you do it well, you live. If you don't, you're off. So it drove the formation of the nervous system and the brain eventually. And what our brain mostly does is that it senses the environment and actions are driven by it. And many of those actions are for survival still. And so when you move from a single-celled organism into an organism that has a brain, what happens is that the sensing of the environment becomes more sophisticated. And why do you have to sense your environment? Because the environment is essentially infinite. Another thing that came up with data in industries, I'm going to keep connecting it back to the talk that we just heard. So you need to make decisions about the data in your environment, or else you're just paralyzed. And animals have to do this to survive. And then things got more complicated. It wasn't just avoiding toxins and finding nutrients, you had to find a mate also, right? So that was like a big upgrade in complexity. So there's a lot of data that has to be interpreted. How most animals, including us, interpret data is through a process called bottom-up attention. And what that means is that decisions are made reflexively without... I wrote an entire book on this topic. I'm going to talk about that. That was the best.
What was that, Adam?
That was the best cue ever. That was a bottom-up signal. I'm going to come back to that. That's really good. That was really good. I enjoyed that, because you make these decisions reflexively based upon things that are occurring in your environment that are very salient or very novel, like a ringing sound, like a flash of light, like hearing your name. These are the signals that drive animals to survive. And the decision that's based on them is not a goal-directed decision. It's a reflexive decision. We all responded to that. We had no choice. That was a perfect example of bottom-up attention. Thank you. That's perfect. We still have bottom-up attention. You know it because we just proved it, right? It exists. It's still critical for our survival. You're walking across the street, see a cutie pie in the distance, and all of a sudden a car comes along. You make a response. You back up, right? Even if you're not paying attention, you still have to respond to it reflexively. Sorry, Fatima said, "Can I get cutie pie into my talk today?" It was a challenge. I saw the opportunity, so I went with it. It made no sense. Ignore that. All right. So bottom up is still there, but humans have evolved what we call as top-down attention, and that's goal-directed attention. So you make a decision to do something. It might not even be in the best of your survival, advantage. And you then control how you process the world based upon your goals. That's top-down attention. We, as humans, have that more than any other creature, far more. I would say that is the source of our ability to create technology and society and music and language and architecture, is that we are not slaves to our environment. We're not slaves to the things in our environment that drive our attention. We make choices. And that is really what Signal Labs is doing. It's really what we've had more than a surplus of are tools that help us collect the bottom-up information and compile it into dashboards. But we still have limited resources. We still have to apply our goals to make decisions and pull out the signals that are most relevant to have the biggest impact. And so I really, really see this vision like in a unique perspective as a neuroscientist. And that collision between top down and bottom up is present every moment of your life. You're constantly juggling those two, and it's influencing you whether you're aware of it or not. Are you focusing on your significant other at the dinner table, or is part of your mind pulling by some pings going off in your pocket or on the table? We're constantly in that interface of bottom up and top down. And to be able to have solutions that allow us to do it not just in our brain, but on the enterprise level is truly special. So thanks for inviting me to be part of this ride. And that's my talk about the universe and everything.
So would it be fair to say, Adam, that when you talk about like bottom-up reasoning, thinking, consciousness, attention, that things like dashboards, things that are data-oriented, systems of record, systems of engagement, AI for that matter, it's trained on data, which is like instinctively that the enterprise architecture reflects that bottom-up thinking.
Yeah, I think its intentions were to help categorize, organize, reduce the infinite amount of information. But it's still a bottom-up source, right? It's not really necessarily in alignment with your goals. It could be it almost is overwhelming in itself. And so its intentions were to reduce the bottom-up clutter, but it just became a way of organizing the bottom-up. It's still bottom-up sources of information, I would say.
Yeah. So when you describe that, in some ways, the architecture that we're building at Signal Labs, which is more a top-down architecture for attention, that's goal-oriented from the top down. Obviously, the bottom-up thinking and everything else is still needed. But the weight sort of moves to the top, and you're saying, sort of this is what you're setting out to do. And so therefore, the signals that matter to achieve those things, together with the bottom-up things that always need to exist, that are data-driven, need to intersect differently. And the weight perhaps need to shift from where it's probably 90% bottom-up today to more like 50-50 top-down versus bottom-up. And so the work that Adam is doing, clinically, in some ways informs the tech that we're building, the user experience that we're going to build around SignalOS that says, how do we really sort of take this translate this work that's brilliant, done in the clinical space, and apply it to institutions? Because let's face it, all institutions have ADHD at scale. So how do we reduce that? How do we get them to focus on the things that matter? And then how do we connect the dots more effectively? So lots more work to be done, but super excited about our collaboration, Adam. But before we end, I want to turn to what's been your life's work with Gazzaley. And I think Adam is both an advisor to Signal as well as a potential customer and partner in the work that he's going to bring to market, where we're going to provide the tech stack for what Adam is building that's really significant in terms of bringing sort of a gaming-based approach and non-pill form approach to attention disorders to be more commercially viable and applicable in an insurance-heavy sort of medical system that we have here. So we'd love for you to talk a little bit about that, and we'll take it from there.
Yeah, I'll just give you the quick rundown. It's an 18-year story, so hopefully you have some time here. 18 years ago, I had an idea about building an interactive experience to improve attention abilities. So this was the sort of flip side to my distracted mind part of my life, which is sort of a bummer. And I was like, I cannot spend the rest of my life showing how our attention is so fragile and all these negative things. I want to use neuroscience to help improve attention by harnessing our brain's plasticity. And so I built an interactive experience as a video game and spent years showing that it can improve attention. We had a paper on the cover of Nature in September of 2013 showing that we improve attention in older adults through this video game. Started a company called Gazzaley 15 years ago, and then over the many years built a way better version of that original game. This is a closed loop video game, means that your data 10 times a second is being used to update the challenges and the rewards in a very personalized way, challenging your attention system at a very high level. And we show that we can improve attention in multiple clinical populations: depression, autism, lupus, all what I told you before. Every population that has an impact of attention, we've shown in around 10 of them now that we improve attention through interacting with this video game just over 6 weeks. And then particularly in ADHD, we did multiple clinical trials, including a phase 3 trial, which we then took to the FDA and got the first and still only FDA approval of a video game as a medical treatment. So there's a prescribable video game for children to treat their ADHD right now called Endeavor. We now have clearances across the entire lifespan. And, it's really exciting. It's a non-stimulant alternative for ADHD that uses video game mechanics to improve attention abilities and behavior. And the data is quite strong. And after 13 years, we hit a wall of commercial development challenges because there were no reimbursement framework for this. And so very hard to scale a medical device prescription-only treatment without insurance reimbursement. For those of you in the field know this well. I see some nodding out there. And so we were sort of paralyzed. Many other companies that had other digital treatments for mental health went bankrupt. And then just last year, Center for Medicaid and Medicare Services released codes, G codes, for reimbursement of these treatments, all digital mental health treatments, not just ours. So we're now in the process of trying to reboot this company and get this treatment out there to all those people in need. And one of the challenges we have is how do we now enter this landscape of so many signals that occur when a child or an adult uses something like this, a treatment like Endeavor. How does it change their life? How does it change their risk profile? How does it interact with value-based care? These are things that I'm learning a lot about to give the incentives that allow them to, their providers to get paid to give a treatment like this. So it's really exciting for me after a 15-year journey to now finally being in that phase where we could scale commercially and really get this to all the people in need. And through partnership with Signal Labs, we're going to take it to the next step. So I'm super grateful to Raj and all the folks at Signal Labs that I've been talking with all the time over the last couple of months to figure out how we can really take this treatment to the next level through the technology you heard about today.
Adam, thank you. You're a member here, so thanks for hosting us at the Institute. Fantastic venue. And one of the privileges of founding Signal Labs has been that of all the great people that I've met over the last 25 plus years of my professional journey, it's giving me an opportunity to bring everyone together. And some are working for Signal, some we're collaborating with, some are ecosystem partners. But it's been a fun ride just to reinvigorate all those conversations, all those relationships. And Adam, you among the best, and thank you for doing this for us.
Thank you, Raj. Thank you, everyone.
With that, I would love to welcome Jeff Klebanoff to the floor here. Jeff leads is our general manager for our consumer markets and is going to take us through a double click and a deep dive on SignalOS and what we mean by it, how it comes to life. And then our CTO, Plamen Petrov, is going to do a little bit of a deeper dive on SignalGraph. So over to you, Jeff.
Thanks, Steve. All right, I'm going to take you through a quick video that sort of brings the problem to life.
And then we'll get into it. Hey, we've got a problem here. What did you do?
Nothing. I stirred the text.
Whoa. Hey. This is Houston. Say again, please.
Houston, we have a problem. We have a main bus being undervolted. We've got a lot of thruster activity here, Houston. It just went offline. Oh, there's another master alarm, Houston.
I'm checking the quad.
There's no refresh valve.
Maybe two quads.
We've got a computer
I'm gonna
restart.
reconfigure the RCS.
We've got a
When these
baseline.
things fire, it doesn't make any
We got
sense.
multiple caution and warning, Houston. We've got to reset and restart.
All right, I'm going to SDS.
Jesus. Like the heart rate's just skyrocketing.
All right, so good example of tons of signals, major challenges. What do you focus on? And this is a little bit of that top down, bottom up, just because that was in space, not as a joke. But basically, you're thinking about, there's all these signals, no one knew what to do, right? So Houston, there was a problem. No one knew what the problem was. And if this clip would have continued to go, there was a question that said, is there actually an issue, or is this just the instruments that are causing the problem? So it's a really good example, and as we get into the rail demo that I'm going to talk about, of where there's just so many signals firing and no one knew what to do about it. And no one actually knew what was causing it. So that was a good example of that. So what I'm going to take you through today is a little bit of the transportation and logistics opportunity that we have, and then we'll actually take you into a demo of the actual Signal platform. So we've been focused on rail, logistics, and freight. So it's a good use case from a supply chain perspective. Obviously, railroads, tons of signals that are happening all the time. You have different situations with independent railroads. You have network railroads. So when we looked at this, there's a massive opportunity as it pertains to the dollars that are being impacted as it pertains to railroads. You have situations where, call it 150 trains are being delayed and no one really knows why. So all the work that's happening from a data perspective, analytics perspective, AI perspective is not actually solving the problem of what's driving the issue as it pertains to the railroads. Multiple disconnected systems. And we'll talk about this from a warning timeline perspective, and the shot clock Raj mentioned. There's only so much time that you can actually act before there's nothing you can do about it. And that's the whole signal decay issue that you're dealing with. So as you get the information, there's only so much time you can actually rectify that as it pertains to the action and the decision. So what we're going to go through is, you'll see there's a multitude of different issues that we're going to be faced with. So we're going to talk about defects that are happening with some of the equipment. We're going to talk about challenges that pertains to the crew. And this is where the equilibrium comes in, because there's only a certain period of time that the people working on the rail can actually work. There's the 8-hour window that they have to stop driving. A lot of people know this if they're ever waiting for their pilot. And then you hear, well, wait, these people have been working too long in the airport. Now you have to get a new pilot. So you guys know that from planes as well. There's storms coming, which obviously impacts trains as well. Chassis shortage. So now we have also an equipment issue, but then there's also a shortage in what we need to actually supply what we have to do. Dock bottlenecks, and then SLA breaches. And what you'll see from this example is there's actually financial implications if you can't actually deliver the freight. And that's a big issue, because now you're talking multi-millions of dollars potentially. So systems don't talk, as we've been talking about. The failures are multi-party. This is where we lack the coordination layer. And then there's trust, big aspect of this. Many companies do not want to share their data. So what we at Signal had to do is make sure that we provided a layer that did not actually expose anybody's proprietary data. And that's what we'll talk about. So as Raj was talking about, it's talking about one neutral layer that we're putting on top. So you can have all the AI, you can have all the agentic, but we want to have that one coordination layer on top that we'll go through. What you're going to see in this example is 9 different data sources that are basically from multiple places that no one is talking. So we have multiple data sources, we have multiple shippers, we have multiple carriers, and there's no alignment as far as what's going on. So when you talk about the cascade, each individual situation is happening, might look minor, but when all of these come together, it's a massive problem for the railroads. The filter that we'll talk about, and Plamen will get into this as well, is the math that is built out. It actually shows those different limits to say, is this really a problem? As Raj was talking about, it's actually doing that back-end calculation to say, is this signal going to really be a problem? Where should I focus my attention? And then we're going to have the routing. So this is actually where we have now ranked actions that actually go to the right people at the right time to make the right decision. So that 3-prong layer is really what's going to drive the ability to get the attention to the right place, to act the right way, and drive the right decisions. And the focus is we're taking it from 9 data sources basically down to one platform. So let me show you the platform. So this is a visual of what the platform could look like. So this is SignalOS for logistics and transportation. And I'm going to take you through a real world example of something that happens when it comes to the railroad and freight that we have to deal with. So you can see on the screen, there's different aspects. So we have a color scheme that says, where do I need to have immediate attention? So when I'm looking at different railroads, I'm looking at different terminals, it'll actually tell me based on all the math and logic where I should actually be focused. So there's immediate, there's elevated, there's green, Dallas is fine, everything's good. There's warehouses, and this is what gives you a view into knowing what I need to be focused on. on the same screen, we included other things. So you have all the monitored entities, and then we actually have a signal intelligence feed. So what this is giving is real-time data, not just internal, but also external. So you can see there is an update as it pertains to a thunderstorm. It talks about the US-Iran ceasefire and the fact that oil prices are still going up, which has an impact from a rail-based perspective as well. It talks about tariffs impacting McKesson's ability to drive supply chain. And so this scenario that we're going to focus on is currently McKesson is trying to move $2.4 million of insulin, sorry, thanks, Fatima, from Chicago to Kansas City. Basically, there's an issue because it's medicine. It has to stay cold. And so if there are any delays, all of that can be ruined because they have to get to a place where they actually have that cold storage. There's 6 things that are going wrong at the same time. There are equipment problems blocking the staging area. The storm is coming. You can see it on, you saw that on the map over Chicago. Crews are hitting their limits and there's no replacement crews. Paperwork's incomplete on multiple cars. We're short on the refrigerated chassis. And there's actually multiple shipments that are fighting for the dock. It's because there's multiple shipments trying to come in. Each of those are manageable on its own, but together, this is where the cascading effect happens. This is where the railroads are dealing with, why are my trains taking so long to come in? Why do I have customer issues? Why am I dealing with these sprayed issues? That's where Signal Labs comes in and really helps you to see that. So I'm going to take you through what this looks like. So Chicago has an 84 number. What does that number mean? Basically, that's taking all the different risk factors from a signal-based perspective that's driving why this terminal is something we need to focus on. You can see all the different areas where attention is required. So you have elevated risk as it pertains to the crew. You have the issue as it pertains to the coldness that you need for the pharmaceuticals. You can see the track 7's got some maintenance going on that's going to also impact. So all of these are different places where we need to actually act. You can actually trigger a review, which will route to the appropriate person that can actually do something about this. So this is where we want to make sure we're focused from a signal perspective. Raj talked about the shot clock. So you can actually see here, this is how much time you have left before you can actually either make a decision or not. So this is going to be a running clock. So you'll know over time, you've got to actually make a decision or the signal is going to decay and you can't do anything about it. This is the risk summary. So you can see this is all red, right? We have a corridor flow issue between Chicago and Kansas City. There's a supply chain cascade issue, as we talked about with what's coming from McKesson. There's terminal and warehouse apps, operational problems, network coordination because no one's talking across the network. And then we have the resource challenge we talked about. This actually gives you where the top contributing signals are. And what this gives you is real-time actions that you can take. Now, just to be clear, Signal is not going to make the decisions. This is not a decision management solution, right? What they will provide is the actions recommended to the company on what decisions that they should make. And this is real time. So this will continue to provide you what are the latest actions you can make to actually impact these issues that you're facing. And then if you keep going down, you can actually see all the signals, all the events, and then there's this concept of a hypothesis. So what this is saying is if we have a crew expiring, we have equipments being held, and then we have this pharma staging collapse, we're going to have an issue. So everything you can see here from a Chicago-based perspective is telling you we're going to have an issue in that terminal. Similarly, if we look at Kansas City, you can see for a distribution percentage, it's elevated, but the same types of issues are going to happen. The storage is a problem. So you can see at where it's supposed to be going to, you can see all the same information, same shot clock and all that information. So this is in one place from a SignalOS perspective, showing you all the information that historically you've had to go to multiple places to look at, multiple systems and multiple people not coordinating. So this in essence is what SignalOS can do. And then we also have the institutional memory. So as Raj mentioned, memory compounds. Nobody's ever tracking all the decisions that are being made, the outcomes that are happening. That's what this is doing. This is actually saying, what decisions did we make? What was the impact of those decisions? And then there's a feedback loop to the beginning. So in the future, when the similar type of scenario come up, we know what decisions we made and what actions we took and what was the impact. And that's where the institutional memory comes in. So with that, I'm going to ask Plamen to come up to actually talk more about the math and science behind it and take us through the signal graph, which is the IP that we've been talking about.
Thank you. All right. So you heard a lot about the vision, and isn't it fascinating? It is. And what is even more fascinating is how do you engineer this? So we have all the signals, and we have an amazing capabilities. But just think about all the data that bottom up has to be tied to the top down attention and create signals. This is a massive engineering problem, and actually it is a massive scientific problem too. So our company is rooted in several fundamental disciplines, with Adam, of course, in the neuroscience of attention and cognition. But also a lot of my work has been in information science and information theory, decision science, game theory. And you'll see it propagates through what our system is doing. In addition to that, it's a massive engineering problem. So it's a, how do you scale this and how do you be smart about that? So usually a lot of people start asking me, so what exactly is a signal from an engineering point of view? And I have a cheat sheet for that. I've been answering so many times. So it is a structured, contextualized, and time-bound representation of a meaningful change, event, pattern, or inference derived from data. So we're still connected to data. However, it is relevant to a decision, to a strategy, or to an operational action. We're connecting the bottom-up data to the top-down human desire or goal, and that's a signal. So a signal generally has some defining characteristics, such as it is derived from data. We cannot run away from data. Data is the kind of a source of that. However, it is contextualized with a business strategy and ontology. It has to be contextualized. Okay, sorry. It is time aware. We talked a lot about decay, and you have only so much time to make a decision and to act upon that decision. After that, you may have all the great signals and all the great attention, doesn't matter. It's too late. And hopefully we didn't, okay. And in addition to that, we have also some level of confidence about the signal. Can we trust that signal? And finally, it has to be relevant to action. If it's not relevant to action, it's just a nice exercise of observing what's going on. So with having said all that, some of the things that I'm not going to go deep into, but some terms that are core to our calculations have to do with information theory. Entropy, basically how much we have unknown in randomness, and how do we reduce entropy with information gain. A lot has to do with Fisher information. How do we actually, how much the observable data improves the quality of the decision and the likelihood of we'll be able to make a decision. And the inverse to that, the Kramer-Rao bound, which tells us what is the theoretical limits of that. So all of that are part of the calculations we do, and we'll talk more about that. So first of all, Jeff showed you what the business person should be seeing. Right? This is the essence of focus attention. However, for people that want to see what's under the cover and want to dig down and maybe debug or understand why something is happening, how it's happening, we've created an axis to see our core signal graph that is kind of under the hoods of our SignalOS. So again, it is not intended to be used by business users. It's, of course, you cannot pay attention to all of that. Having said that, if you learn how to use it, and that's your job, you can quickly start to decipher how things are happening. So you can see our graph has different nodes. So it's a heterogeneous graph. So nodes can have different types of, of different types. And as an example, we can filter. We have terminals. This particular case, we tuned our information and data to a railroad and logistics use case. So signals are extracted from railroad and logistic data, but also with the goal of serving a business, the business goal of that particular use case. So what matters in this particular use case are things like terminals. There are triangles in this particular graph. We also have warehouses, like we have here the Chicago Midwest Fulfillment Center, and we have here the LA South Distribution Hub and so forth. We also have data sources, these bubbles here, or more like the chassis registry, and we have here the crew management data source, the railing equipment health management system, and so forth. And then we have our signal nodes. As an example, elevated diesel surcharge cascading. Our nodes have different dimensions, so I can reduce the complexity by saying, okay, let's look at the Chicago clearing. So the Chicago clearing terminal or yard is in the middle, and then we may say, let's look only at the corridor dimension, and we can see the sources that drive into the signals, and some of the signals here are, let's say, clearing yard throughput degrade. And if you click on that, you can see some of the math and some of the calculations we're doing. So first of all, it has passed our Kramer-Rao bound or limit bound. So it is above, here is a calculation of that. CRLB bound is 0.11, it's green. It is the inverse of the Fisher data. And you'll see in another screen, we have the calculation, all the formulas being calculated. So LLMs does not live outside of statistics. LLMs have to live within the reality of statistics. We just connect the dots. We just make sure that we bring back the rigor and information theory validity to the power of LLMs. We have the signal decay calculation, with its half-life, and there's the formula if you want to. It's not that complex, but basically it tells you how much time you have to act, and it's updated in real time, of course. So we also have the evidence out of the different sources. How did we calculate the signal, and what is the level of urgency for that signal? So this is kind of our signal graph. If you think about it, just think about the complexity of implementing that. So obviously our engineering, we have some of our engineers here in the room. We're very proud of that. So we have to be able to scale for the GPU era. And the representation has to be such. Also, it's engineering plus information theory. So we're not storing all the data. That's crazy. It doesn't make sense. It has to be compressed, information compression, only to the data that is meaningful for the signal and for the making a decision. What else do we want to see here? Let's jump. So data sources, of course, data. You need data. We live in the world of data. We just combine top-down, bottom-up, and meaningful signals. So in this particular case, we have 13 connections, data sources, as you see. Part of our engineering has to do with very rapid development of, or customization and configuration of adapters to different data sources. Of course, with the beauty of the latest AI capabilities, we can do it very quickly. And as you can see here, we can both read. This is a instantiation for reading from a Kafka stream. We're reading REST APIs. We had a Postgres was one of the. We have a Snowflake and so forth. In addition, different types of data representations, and all of that goes into our semantic layer. So we have to ground it into a business meaningful and signal meaningful understanding of the data. Again, just probably we have here the different signal objects like dwell time, lead time, hub capacity, and so forth. There's a description for people to quickly understand what that particular signal is, and at this point we're kind of very explicitly capturing some of the calculations. So there is a understanding and of evidence of how these signals have been calculated. We have thresholds for this signal. At what point it is either minimal or elevated, or normal, elevated, or critical. And the combination of signals in the context of a stable ecosystem is our equilibrium. And we detect signals that indicate that there's a risk that we're going outside of that equilibrium. A lot of the world that we live in has multiple parties, multiple trading parties. Like in this case, in the railroad example, we have many terminals, many train companies, Northern Pacific and Norfolk Southern and so forth, that share common rails. And they are both working together and competing for shared resources. And there's an equilibrium where the ecosystem is successful. And if you bounce out of that equilibrium, there's systemic issues. And we provide the ability to detect signals for those. Right now, we're running on Claude. So this is on Opus 4.6. But we are not LLM, so it's our first release. So we are fairly flexible to be able to plug into others. So don't know how much you want to get into the math. As I mentioned, Fisher information allows to calculate how much different signals are relevant statistically from observable data, and the Kramer-Rao lower bound gives us that measurement. So we also have, of course, as I mentioned, the signal to noise ratio. So a lot of information theory calculations that we plug into the LLM world. And finally, so that we also have the equilibrium, as I mentioned, that allows in a multi-party system to find that middle ground. We're very excited about our healthcare use cases, building equilibrium between payer, provider, and pharma, and both at the contract level and at the reimbursement level. So there's a lot of opportunities. So with all that, I think that's kind of what's under the covers. A lot of development going on. Our first release coming up April 24th, and we have releases every 6 weeks after that. Very excited to have our clients from different industries. Our model is, our whole development is structured as such that we can very rapidly and quickly connect to different industries. So we view the signal layer as the top layer that plugs into different data. Depending on the maturity of our clients, in certain cases we're going to plug our signal layer at their source systems. Other more mature companies may have a more sophisticated warehouses. We can plug it like different bronze, silver, gold layer in a medallion architecture. So there are different, we're not replacing, we're literally the smart signal on top and attention layer on top of existing data and AI and analytics infrastructure. With all of that, I'll bring it back to Jeff to close it.
Oh, thanks, Plamen.
Data is everywhere. Signals are not. The signals were there. They always are. Despite years of investment in systems of record, analytics and insight, 52% of companies on the Fortune 100 list from the year 2000 no longer exist today. SignalLabs builds the attention infrastructure enterprises need with signal ingestion, equilibrium engine, attention engine, and institutional memory, captured in a signal graph, convened by SignalOS. Act before value decays. Route the right signals to the right decision makers before the window closes. With SignalLabs.
All right, so that was the closing video. Again, just wanted to thank everybody for participating and coming out for this event. Super excited from a SignalLabs perspective to be kicking off. I met Raj a couple of months ago, and it's been an incredible ride the past couple of months. I do want to take a moment just to thank Raj for all of this, because none of this would have been possible without him. He brought all of us together, and this was his vision. So we're super excited to bring this to life. And, you know, when he talked to me about this, I've said, this is different, this is necessary, and this is the time for all of this. So it's great timing for this. As Raj said, a new era. And I do think what we're coming up with is going to truly change the game as it pertains to decision making. I did want to thank Sam for coming out. We're going to have a good partnership there. Lightspeed, obviously, for playing a role in all of this. Adam, this is ridiculous, an amazing place. Views are incredible. Sam and Infinite as well for your involvement and support. So really super excited. And AWS as well is here. So great partnership there as well. So thank you for coming out. All right, but thank you again. Go Signal Labs. This is it.